let's apply then what we've just been doing to solving quadratic equations to a trigonometric quadratic equation. Yeah, try saying that after a few beers. It looks very similar to the one we've just been looking at, except it was x squared minus 6x minus 6 equals 0. Now we've got some trigonometric functions in it as well. But all we do is we just let cos x equal some other letter, say y. Okay. So then we can rewrite it. Instead of cos squared x, I write y squared. Instead of 6 cos x, I write 6y minus 6 equals 0. So in other words, I just make a substitution. I let the trigonometric term equal another letter and then work out what that y is. Once I've worked out what that y is, which we've done actually if you think about it, then with that y equals cos x. So once we know what y is, we can work out what x is and go back to that original equation. So that's the way you do it. Notice that if I plot it, we get an infinite number of terms in this thing. This curve carries on, and I've just written the curve within a range of values we're interested in it. So solve this equation for values between 0 and 360 degrees. So 360 degrees will be about here somewhere. So what's the solution to this equation? Two solutions between 0 and 360 degrees. So those are the two that we're after. Okay, so let's go ahead and do it then, because we've already calculated what y is in the previous video clip, or just a minute or two ago. What were the two solutions that we had? So solving y equals negative 0.87, was it? Or 6.87. So we use the normal method for solving quadratic equations to get y. So y equals, so therefore sine of x equals negative 0.87 or 6.87. Yeah, that's right. However, makes no sense. So we've got to then think about applying this to a trigonometric function. If we look at the sine function, sine of x, it goes between +1 and -1. So if I type in, if I try and find that value, I'm not going to get an answer. So all values must lie between 1 and -1. So this is the one we're after. So therefore, the solution, our solution, is negative 0.87. So sine x equals negative 0.87. So what do I do to get x? No. If I know what sine of x is, what function on the calculator allows us to find x? Sine to the -1. So x equals sine to the -1 of negative 0.87. So now just get my calculator out and work out what that is. And if we want it in degrees, check you in degrees on the calculator, which we do in this example. Radians, check you in radians. So x equals -60, but remember in this case question we're after values of the angle between 0 and 360 degrees. So minus 60 does not lie in the range that we're interested in. So the calculator now doesn't help us. What we have to do is picture the wave as we've done before. Minus 0.87, which is this point here, gives us a value of minus 60 degrees. But what we want is this value and this value, those two values that lie between 0 and 360 degrees. And so we use the symmetry of the curve that we've talked about before. Well, yeah, the symmetry between here and here, say, this point, that's minus 60 back from there. So the first one is going to be 60 back from 360, which is 300 degrees. Yeah, so the first one is going to be, so that's going to be 300 degrees. The next one, which is this one, be 180 plus 60, which is 240, yeah. So you just got to rely on the symmetry of the thing, and that will then give you your values for x. So the two values of x that we're interested in are 240 degrees and 300 degrees, which the calculator won't give you because it only works in the quadrant between plus 90 and minus 90. So it'll only ever give you the values between plus or minus 90. You've then got to work out which values you want. So let's look at this problem, and in the light of what we've been talking about today. First of all, you've got to solve this equation within the range 0 to 360 degrees, so we're working within this range again. But think about the quadratic equations that we were looking at before we looked at this bit, and the examples where you've not got one of the terms. In this one, we let cos x be our, or cos of a rather, be our x or our y, whatever we want to call it. There is no x term, there's no cosine term. So that makes it quite straightforward to solve. So look back at the notes we were taking on solving linear quadratic or ordinary quadratic equations to help you with this. And I'll just pause this for a little while you have a go, and then we'll look at the solution. Okay? See if you can come up with the values for a between 0 and 360 degrees. So to solve this, we let cos a equal y, which means that the quadratic equation then becomes this. Solving it, rearranging, we get y squared equals 0.5, or y equals plus or minus 0.71, or 0.7071. Actually, it's probably best to leave it like that. If we then put in, we plus 0.7071, we get 45 degrees, minus, we get 135 degrees, because the calculator gives us those values. Oh, interesting, it gives you that. But remember, we're interested in all the values between 0 and 360 degrees. So at this stage, we need to sketch it. And when it comes to the assignment, it asks you to sketch and verify your results. So sketch it between 0 and 360. It's a cosine function. That's wrong. Cosine function. So it starts at 1. It goes like that between 0 and 360 degrees. We've got minus, plus or minus 0.7071. So we've got plus 0.7071 and minus 0.7071. So at this stage, you don't really need to put it into your calculator to get the values. Well, I suppose you do to get one of them. But once you've done that, you're then after this value and this value for the minus 0.7071, and this value and this value for the plus 0.701. So you're going to get 4 results for this case. There are 4 angles that will give you the correct solution. Okay? So just write down what those 4 are. In the light of what we've just been writing down, put those on here and then write down those solutions. So we get those 4 values, 45 degrees for the first one, but then going across and from the symmetry, 360 minus 45 gives you 315, and then the negative result, 135, which is 45 more than 90, so we've got to come 45 less than 270, to get 225 degrees, right, from the symmetry. Okay, so that's how you go about these questions. But just before I leave this, I want to point out one error that I was thinking about while you were having a go at that. If we go back to the previous question, we came up with values of 240 and 300. And I went back to here while you were doing that just to check it against this, and I thought, well, that doesn't bear out this sketch. And then I spotted the deliberate mistake. Let cos x equal y. And what did we do at the end? Sin x. So as a little extra activity, if you want to, repeat this last little bit with cos x instead of sin x, and you should verify the answers on that curve at the top. So sorry about that, okay? Right.